Number 3. What is the Lewis structure for the nitrate ion? So NO3 minus. Include all resonance forms and formal charges. So first, let's calculate the total valence electrons in the NO3 minus ion. So nitrogen atom contains 5 valence electrons. Each oxygen atom contains 6, and there are 3 of them, 18. And notice we also have a negative charge on the entire molecule, so I'm going to add an extra electron. And then if we add this all up, we should get 24. So now let's draw nitrogen as our central atom. And we'll show all the oxygens. Okay, so now I will fill in all of the electrons. And before I fill out the last one, let's count out how many I've drawn so far. So we have 8, 9, 10. If we recall that each bond contains 2 electrons, I have so far drawn 10 electrons and I need 24. So notice that nitrogen doesn't have a full octet yet, so I'm going to draw a double bond and fill it out. And now let's count out how many electrons are here. So 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 electrons, so all of them have been drawn. And now let's show the charges. So the nitrogen has a positive charge, which makes sense since it is the least electronegative. And the 2 oxygens, which are more electronegative, are more likely to carry the negative charges. So since one of the negative charges is kind of cancelled out with the positive charge, this overall molecule has a -1 charge, which is good, which is expected. So this is one resonance structure of NO3-, so we can draw another one with a different oxygen having the double bond. Just showing all of the electrons still as well. So now these 2 oxygens have a negative charge. And lastly, we can have the rightmost oxygen having the double bond, and the other 2 are singly bonded. Like so. So now I will do a sample calculation for formal charge. So let's try to fit it up here. So the equation for formal charge is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. This is the equation for formal charge. So I'll do the one on the most left, and I'll label all of the different atoms. So since these two oxygens are the same, I'll just label the 1. Oxygen 1 and 2. So for oxygen 1, which is one of the single bonded oxygens, we are to calculate its formal charge. We already know that it is -1 because I've drawn it in, but let's say we didn't know. This is how you would calculate for it. So for oxygen 1, it has 6 valence electrons. For the number of non-bonding electrons, these are the lone pairs. So it has 6 non-bonding electrons, and the electrons participating in the bond is 2, and this number is divided by 2. So that's how oxygen 1 has a -1 charge. Now let's do the same thing for oxygen 2. It also contains 6 valence electrons. The number of non-bonding electrons is only 4, and the number of electrons participating in the bond is 1, 2, 3, 4. So 4 divided by 2, which is 2. So this oxygen has a formal charge of 0. Now let's do it for the nitrogen. Nitrogen has 5 valence electrons. It has no lone pairs, so for non-bonding electrons I'm going to write 0. And the number of electrons that are participating in the bond, so there's 4 bonds. So there are 8 bonding electrons. And this is how the nitrogen has a +1 formal charge. Okay, so now let's see what the junior tutor said. NO3 minus. The number of valence electrons is equal to 5 plus 18 plus 1, which is equal to 24. The least electronegative is the nitrogen atom, so that's the one that will carry the positive charge. And you can see the 3 different resonance structures. Formal charge is equal to number of valence electrons minus number of non-bonding electrons minus number of shared electrons divided by 2. Okay, so this solution is correct.